occupied by 1.8 grams of water vapor at 374 degrees Celsius and 1 bar pressure will be how much? Okay, we need to find the volume. They given 1.8 grams of water vapor. So 374 degrees Celsius at these conditions. Then how much these water occupied the volume? Okay, the volume occupied by the water is how much? So use the PV equal to nRT formula. PV equal to N into RT. Use this formula. Find the number of moles. So the number of moles equal to weight by molecular weight. Okay, weight of the water vapor is how much? 1.8 grams, and molecular weight of the water is how much? H2O. Here we have the 2 hydrogens and 1 oxygen. So atomic weight of the hydrogen is 1. Atomic weight of the oxygen is 16. So 2 plus 16 is how much? 18 units. This is a molecular weight of water. Molecular weight of water is 18 units. So 1.8 by 18 is how much? That is 0.1. Okay, pressure already they given that. Pressure is how much? Pressure is 1 bar. So just substitute in these formulas. PV equal to nRT. Remember this formula. PV equal to nRT. So pressure is how much here? 1 bar. 1 into V. What is our number of moles we got here? That is 0.1. What is our value? 0.083. And temperature value, it is in degree Celsius. Now you convert into Kelvin. So temperature in Kelvin, 374 plus 273. How much it is? Yes? 647 Kelvin. So temperature is 647. Okay, so when you do this multiplication, then you will get the answer, that is 5.37 liters. Okay, so volume occupied by water vapor at this temperature is how much? 5.37 liters. Means 1.8 grams of water when you evaporate it at this temperature, 374 degrees Celsius. So it will occupy how much volume of the room? That is 5.37 liter of volume it will occupy. The answer is D. Given van der Waals constant for ammonia, hydrogen, oxygen and CO2 are respectively 4.17, 0.244, 1.36, 3.59. Which one of the following gases is most easily liquefied? Okay, which one has higher value? The ammonia has higher value. That is how much? 4.17. Compared with other gases, ammonia has higher value of van der Waals constant. Means if A value increases, what happens? Intermolecular force of attraction values increases. Then gases molecule attract to each other. They become very easily liquid. Okay, and they form liquid. Means gases molecules come close to each other because of intermolecular attraction force. They become liquid. Okay. Now our answer is here. A is matched. Equal moles of hydrogen and oxygen gases are placed in the container. Equal moles of hydrogen and oxygen gases are placed in container with a pinhole through which both can escape. What fraction of oxygen escapes in the time required for one half of the hydrogen to escape? Here time is same and number of moles of oxygen and hydrogen initially they are same. Means initially the number of moles of hydrogen and the number of moles of oxygen both are in, let us assume they are in 1 mole. Okay, let number of moles of hydrogen equal to number of moles of oxygen equal to 1 mole. Okay, through pinhole, how much hydrogen is escaped? How much hydrogen is escaped in the same time? Half of the molecule of hydrogen is escaped. Okay, in same time, number of moles of hydrogen escaped is how much? Let us assume that is how much? Half mole. Okay, the number of molecule of oxygen in the same time escaped is how much? That is you have to find out. Okay, so what is the formula to find out this? Formula is rate of diffusion of hydrogen gas by rate of diffusion of oxygen gas, which is equal to root over molecular weight of oxygen gas by molecular weight of hydrogen gas, which is equal to, here number of moles they given. So here time is same, no need to take the time values here. So that is number of moles of hydrogen by number of moles of oxygen after certain time. Okay, so you make these two are equal, then you will get the answer, right? So What is the molecular weight of the oxygen? Molecular weight of the oxygen is, yes, oxygen molecular weight is how much? 16 into 2, 32. Hydrogen molecular weight is 2 hydrogens, 2 into 1 equal to 2. Okay. The molecular weight of the oxygen is 32. Molecular weight of the hydrogen is 2, which is equal to number of moles of hydrogen is, we have here half mole by number of moles of oxygen. So 2 how many times it is? 16 times. What is the value of root 16? Root 16 value is 4. 4 equal to 1 by 2 by number of moles of oxygen. Okay. So from this we can cross multiply this. Do it cross multiply. 4 into number of moles of oxygen equal to 1 by 2. Number of moles of oxygen equal to 1 by 2 into 4. When you take it this side, it will become by 4. So answer is 1 by 8. Okay, how much fraction of oxygen is escaped in the same time? 1 by 8. The answer is 0. This is after certain time t, the same time t. Okay, that is how much. Answer is 1 by 8. A gas such as carbon monoxide would be most likely to be obey the ideal gas law. Means, listen, for ideal gas, the attraction forces are completely attraction for, there is no attraction forces, there is no repulsion forces for ideal gas. Means the gaseous molecule has to move far from each other. Okay, so for that we require low pressures and high temperatures. So which one is the right answer here? Answer is D. When you apply the high temperature and low pressure, the gas molecules move far from each other. Then the real gas behaves as ideal gas. When there is no attraction forces between the gas molecule, means real gas behaves as ideal gas. For that we require high temperatures and low pressures. Maximum deviation from ideal gas is expected from. Here we have the methane, ammonia and hydrogen and nitrogen gas. So among all these, which gas has more intermolecular attraction forces? That is ammonia. Why? Because this is polar molecule. Because of that nature, it has more attractive in nature. Okay. If gaseous molecules attract each other, they come close to each other and they become liquid. Okay. That means here they deviated from the ideal gas behavior. Okay. So which gas is deviated from the ideal gas behavior? That is ammonia. Why ammonia only? Why? Because it has more attractive forces. Right? The answer is B here. What is the density of nitrogen gas at 227 degrees Celsius and 5 atmosphere pressure? R value given here. Okay. So use the ideal gas equation. That is PV equal to nRT. PV equal to nRT. So N we can write as weight by molecular weight into RT. Okay. So PV, yes, this volume you take it this side. This will become weight by volume into RT by molecular weight. Okay, RT by molecular weight I am writing as M here. So mass by volume is density. Okay, the formula became like this: P equal to dRT by molecular weight. So use this formula and find out the answer. Okay, use this formula and find out the answer. Do it. So from this you find the density value. How do you find the density? Density equal to pressure into molecular weight by R into T. What is the pressure value given, Era? Pressure value is 5 atmosphere. What is the molecular weight of the nitrogen? Yes, molecular weight of nitrogen molecule is, yes, 28. So 5 into 28 by R value is how much here? 0.082 into temperature. Just you convert into Kelvin.
500 Kelvin.
So this is 227 is there. Just you add 273 to this. So it will become 500 Kelvin. So temperature equal to 500 Kelvin. Okay. So just substitute here 500. So 500, 100. So 0.08 to, you assume as 0.08 into 100. So that is equal to 28 by 8. So 8 3 is 24. 8 5 is 40. Okay, around it is nearer where it is matching with 3.41. The answer is C. So it is the density. Density means gram per ml. Okay, the answer is C. Now see here, for real gases, Van der Waals equation is written as P plus n square by V square into V minus Nb equal to nRT, where A and B are the Van der Waals constant, and they given here the two sets of the gases, oxygen, carbon dioxide, hydrogen and helium given in the set 1, methane, oxygen, hydrogen given in the set 2. The gases given in set 1 in increasing order of B and gases given in set 2 decreasing order of A. Okay, and this set 1 gases you have to arrange in the increasing order of the B. Okay, the gases given in the set 2 you have to arrange in decreasing order of A. What is B indicates? B indicates size, right? B indicates size. What is the A indicates? Intermolecular attraction forces. What is the B indicates? Intermolecular attraction forces. Okay, if A decreasing means attraction force decreasing order, so you arrange in attraction force decreasing order. So among all these molecules, so which one has more attractive force, which one has less attractive force? Now you see in the set 1, you compare the molecular weight or size of the molecule is equal to the molecular weight of the molecule. Size is directly proportional to molecular weight, right, or atomic weight. What is the oxygen molecular weight is? Oxygen molecular weight is 32. Carbon dioxide molecular weight is 44. Hydrogen molecular weight is 2. And helium molecular weight is, atomic weight is 4. Now you see, among these molecules or atomic atoms, helium, which one has more in molecular weight and that occupies more in size, right? So which one has more in size here? Carbon dioxide. You have to arrange in the increasing order of the B, means less value to more value. Which one is lesser in size? Which one is lesser in size? Hydrogen. So which one is next lesser in size? Helium. Next? Oxygen. Next? Carbon dioxide. Okay, this is a B and increasing order of size. Okay, this is a set 1 molecule. And set to 2 molecule, you have to arrange in decreasing order of intermolecular attractive forces. Now already you know that hydrogen molecules has more repulsive forces. Z value is greater than 1. Already we have discussed this, right? Z value is greater than 1 for the hydrogen molecule. Means hydrogen molecules has more repulsive forces, means less attractive forces. So hydrogen should be lie in the last position. So answer here matching your this one. So second one is methane has more attractive forces compared to the oxygen, and hydrogen has less attractive forces, it has more repulsive forces. Okay, and this 1 and 2, which option it is matching? So your option C is matching. The answer is C. Okay, is it clear everyone? Yes.